Hello, this is Brother Tony, and today we're going to look at second-order determinants and Cramer's rule. And from your book, it starts out the section by saying, solving a system of equations is fairly tedious, especially if the coefficients are large numbers. And I would also include if they're fractions. So what I'm going to do, the first part, is I'm going to go through the theory of this, and I'm going to describe on the left side how the determinants are gotten, and then on the right side I'll go through it with the actual numbers. Please write this stuff down in your notebook, take good notes, come to class ready for questions. So the first step is to multiply the top equation by the coefficient of y. In this case, the coefficient stands for e, right there. And the second equation gets multiplied by the coefficient of y, which is b. And we would write this, once it's all multiplied through, as a times e times x plus b times e times y equals c times e, where a, e, b, and c are all constants. We do the same thing for the second equation. D b times x plus e b times y equals f b. We subtract the first from the second, in essence multiplying through by a negative. That makes it negative dbx, negative, negative. What cancels out? The middle term cancels out, and we get a e minus b d times the quantity x equals c e minus fb. Okay, so now what does that look like here? We multiply through by negative 7 on top, multiply through by 4 on the bottom. Negative 21 x minus 28y equals negative 14. 20x minus 28y equals positive 68. Now we have to subtract the second from the first, meaning we multiply through by negative 1. So that's a negative 20x plus 28y minus 64. Negative 41x, that cancels out, equals negative 82. X equals 2. Do we do the same? Does it equal the same on the left side? If we solve for x on the left, x equals c e minus f b divided by a e minus b d. X equals, so c times e, 2 times negative 7, negative 14 minus f times b, 17 times 4, 68 divided by a times e, 3 times negative 7, negative 21 minus f times b, 17 times 4. BD. 4 times 5, 20. That equals negative 82 divided by negative 41. X equals 2. So now we've solved for x. What we can do is we can solve for y. So we do that by ignoring this. And so using the same formula, we would get that y equals a times f minus c times d divided by a times e minus b times d. In reality, what does that look like? Y equals a times f, so 3 times 17, 51, minus c times d, 2 times 10, 2 times 5 is 10, divided by a times e, 3 times negative 7 is negative 21, minus b times d, 4 times 5, minus 20. 41 divided by negative 41. Y equals negative 1. So let's make sure we check that. So remember, x equals 2. So we can use either one of these equations. Let's use the first. 3 times 2 equals 4 times negative 1. Sorry about that. 3 times 2 plus 4 times negative 1 equals 2. Is that correct? 6 minus 4 equals 2. So good. Our answers are correct. To review, from the previous two slides, what we saw is to solve for x, this is the equation we use with those coefficients. To solve for y, here's what we use. Now notice the following. Both denominators are the same. For x and for y. Contain only the coefficients of the left members of the equation. The numerator for x does not contain the x coefficient. C times e minus b times f. The numerator for y does not contain the y coefficients, d and e. If you have that, now we're going to get into determinants and how to use Cramer's rule to quickly and easily solve systems of equations with two equations. Here is a formal definition of a second-order determinant. Please write that down in your notes. A second-order determinant is a square array, in this case 2 by 2, 2 rows, 2 columns, of a number that is expanded or evaluated according to the rule. R times u minus s times t. R times u, so we cross multiply, s times minus s times t. So this determinant is evaluated like this. So if you remember from the previous slide, the denominator for both x and y is always the same. And we see that right here. AE minus DB, AE minus DB. So how would we write this as a second order determinant? So the denominator wrote A, B, D, and E. And what does that evaluate to? AE minus DB. So let's populate this array. AB, 3, 4, DE, 5, negative 7. So now we do the second order determinant. 3 times negative 7, negative 21, minus 5 times 4, 20. So the denominator equals negative 41. Should seem familiar. We've gotten this before. The numerator for x now equals the second order determinant that has the array C, B, F, E. The numerator for y, second order determinant, A, C, D, F. So now at the bottom, if we want to solve for x, we take the second order determinant, the numerator of x, divided by the second order determinant of the denominator, right here. For y, second order determinant for the numerator of y, divided by the second order determinant of the denominator. What I want you to do before you come to class, I've given you a system of equations, 5x plus 2y equals 11, x plus y equals 4. I want you to solve this using Cramer's rule and second order determinants. Put that in there and show the work in your notes. I'll see you in class.